What's up, everyone? This is Fabio Cruz, and this is my final project for CIS3367. So for my final project, I wanted to use Solver and do an optimal product mix. I took inspiration for the groundwork of my Excel sheet from the Desert Airlines homework assignment. When trying to determine what types of products or services I wanted to feature in the Excel sheet, I came up with a scenario I thought would be fun and interesting. Scenario is Michael Jordan and Nike decide they're no longer going to manufacture or sell any of his sneakers. In advance to this, they're going to do one last hurrah and sell a mix of all 23 shoes totaling 2.3 million pairs total worldwide. This maximum number and most numbers are inspired by Jordan, who wore numbers 23 and 45 during his playing days. He won 6 rings. There's also one solver constraint, which is 32,292 career points multiplied by 3. So that's how many points he had, and the constraint is 96,000 something. You'll see that when we get to it. But just going through this website, which has a ranking of the top 25 shoes, 23 shoes, and that's what I used for my sheet. So I found a website, soulcollector.com, which had Nike's average cost for a $100 shoe. So you can see here they had their bill of materials and shipping, freight, tax, whatnot, and this gave us a breakdown of approximately what it cost them to manufacture a $100 shoe, and then how much profit or revenue they made. So I took everything here and multiplied it by 1.9 to match the average selling price of a Jordan Air Jordan shoe, which is $190, and I got these numbers. So using that, I then crafted this table. This table lists all 23 pairs of shoes in order of popularity according to AirJordanShoesHQ.com. And so I came up with a rarity multiplier, which, as you can see here, is a little bit crazy, but I just had to get creative with my values. So it's 2016, the year we're in, obviously, minus the year the shoe was released, divided by Jordan's number of 23, divided by its rank, and then divide that by 0.5. And the 0.5 was in order to get a fairly reasonable number here. But again, this is all made up, and it's not scientific or anything. It's just something that I used to create the project. So we have the rankings here, and then I calculated the weight. Again, it's 23 times 23, and I just divided that. Subtracted 23 all the way down, and then I multiplied that by the weight by the points per weight, which is then 43.5. Again, these are all values that I just calculated. So this was calculated by doing the total amount of points, which I just said is 1,000, and dividing that by 23. We then have the dollar worth, and this is by popularity, how much of the selling price the shoe is actually worth, just based upon popularity. So, for example, the number 1 most popular shoe is worth $190, whereas the 23rd most popular shoe is actually only worth $99, where the wholesale price is $95, which brings in a little bit of profit. So, again, using that dollars by popularity factor, which I calculated, subtracting the wholesale price of $95, we have here our expected revenue. So I took all of these values, and then I put them into the solver table that I created based upon the framework that was given to us in the Desert Airlines homework assignment. And so we have here a constraint section, a constant section, which is the 3 locations or 3 regions where we will be selling the shoes. So we have the Americas, we have Europe, and we have Asia. And again, these are somewhat arbitrary numbers, but I have sea freight and insurance for Americas, Europe, and Asia, along with duty and tax. We then have the factory bill of materials here, and the selling general administrative expenses here to give us a total production cost of $76 per shoe, or per pair of shoes. So those do not change. We then have the shoes in 1 through 23 here. I have the maximum number of production, so this is a constraint of how many pairs can actually be manufactured. The shoes that are highlighted in green just means that they're actually available right now. Not that it really matters in regards to this, but just something I thought would be interesting. So then here we have the changing cells. We have all 23 pairs plus each region that they will be sold in, and we have the total for each pair here, and I just inserted the data bars, data validation, just for visual effect. And then we have the freight insurance, duty tax, production, yada yada, and the rarity multiplier, which was something that I created again here just to make the cost of manufacturing the shoe different, because all of the costs were identical. So obviously it was just going to say, hey, this is the most popular shoe. Actually, this one, the 11s, are the most popular shoe, and all the costs are the same. So this brings in $190 minus the cost. Sell 100% of these. Well, that's not interesting, and yeah, it shows solver, but it just doesn't make it an interesting spreadsheet, because it'll be all zeros and then basically the max number that I've set here all the way across. So I created the rarity multiplier in order to differentiate the total cost, quote unquote, of manufacturing the shoe, or at least in this case 3 pair of shoes, because it goes across. And if I show you the formulas here, you'll see that so it's similar again to the desert aircraft assignment. We have the shoes here multiplied by the constants and all that stuff at the top, and that goes all the way across, and it looks a little crazy, but that's just because it's going from cell to cell. So if we go back, so let's go into Solver and actually solve this. And before I do that, at the bottom here we have the gross profit, which is what we're trying to maximize. And then we have 2 charts just for sales by region and shoes by region. So yeah, let's do Solver. And all the constraints are already in here. So similar to the Desert Airlines assignment again, I made this all integers. And here's that constraint I was talking about. So it's Michael Jordan's career points times 3, which is the maximum number of shoes that can be manufactured for any region, actually for a certain pair. And then there's the constraints of I want them to manufacture at least 4,500 of each pair, because again, it'll just make 100% of whatever the most profitable shoe is, which is not interesting. So then there's a maximum of 800,000 shoes per region that can be manufactured. So we have the objective cell, which again is the gross profit cell here. We want it to be maximized. We're changing the cells that are highlighted in yellow. There are the constraints here, which is these guys are just the total number of shoes here can't be higher than the max production. And then here the G41 is this cell, which is 2.3 million, which is the total number of shoes that we want to produce. So let's go ahead and hit solve there. And we're going to keep the solution. And as you can see, even with all the constraints and the rarity multiplier and dollar by popularity, we still have obviously a few pairs that are more profitable, so it's just making as much as it can of those. But Solver worked, and we have our total cost of production here. And then we can see our North and South America sales, Europe sales, Asia sales. And then, so if we were to manufacture these 2.3 million sneakers, we would get a total profit of $359,441,112. And that is the max profit based upon all the constraints that I have set. And these sales costs here, or sales totals here, I actually did those with the sum product. So I am multiplying the dollar per each shoe by the America sales, the Europe sales, Asia sales. So the sum product came in very handy there. And so we're going to go back, and the last thing I did was I just added a little macro here just to reset Solver. So you can reset it and everything goes back to 1. It looks boring, blah blah blah. But if you want, you run Solver again and you get your maximum gross profit for selling 2.3 million pairs of Jordans. And that's my Solver project. I hope you enjoyed it. Thank you very much.